Let's skip 16. We'll do 16 tomorrow. And I want to go to using inverse properties. Now, notice, just do not find the inverse. We'll do that next. It says using inverse properties. Now, when I first started teaching you guys log yesterday, the day before, whatever it was, I told you guys that log undoes exponents, and exponents undo logs. Okay? So, number 17, I have log base 6 of 6 to the third. Now, is this y here, 6 to the third, is that not a power with a base 6? Okay, so that's a power. Log base 6, it's the same base. Don't they undo each other? So what's my answer? 3. You just told me what it was. Yeah, you did. You went, How about number 18? My exponent base is what? And my log base is what? Don't they cancel each other out? So what's my answer? Maybe. We'll keep going and see if that works for all of them. Probably not, knowing mathematics. Okay, what's my power base? E. What's the base of the natural log? E. Right? If it's not there, it's natural log, so the base is E. What happens to the base of the exponent and the log? Cancel out. So that was my first question. My answer is, okay, number 20. Uh-oh, something different. Not going to work, is it? Why is it going to work? Because there's a 2 in between the E and the log. Is there any way I can get rid of the 2? Well, kind of. I don't know why they put the. I don't know why they put this. I don't know why they put this in this section, but there's a property that says, see my log is 2 ln of 3. If I have a number in front of that log, I can put it in as an exponent of the 3. So I have e to the ln of 3, oops, there should be 3 squared, right? So what's my answer now? These cancel out. 3 squared, which is, that's right, 9. All right, let's see, 21. I have a number in front of a log. What am I going to do with it? Put it in as an exponent of my y, right? I have ln of e to the 3 raised to the 5. What is ln of e 3 raised to the 5? What's ln of 3 raised to the 5? How about the exact value? What's 3 times 5? Thank you. Okay, now the natural log cancels out base e. What's my answer? But the power raised to a power. A power raised to a power. If I have b to the x and I raise it to the a, I multiply the exponents, so I get b to the xa. Come on, guys, you know this stuff. This is like 7th grade. Doesn't matter. All right, number 22. I have the common log here, right? What's my base? 10. I have a base 10 there. I have a base 10 for my power, so they cancel each other out. What's my answer? Yep. Nope, we're learning it right now. Okay, number 23. I have log base 3 of 9 to the x. Now, I have to have a base 3 for my power, right? How can I make 9x a base 3? How can I make number 9 a 3? Okay, square root. So what is it? 3 squared, right? Don't forget the x. So log 3 cancels out power base of 3, and I'm left with 2x. Okay. It's easy, but you really got to pay attention and not talk in a group or play video games. Okay, now 24 through 26, it says find the inverse. How do we find inverses? What's the process? Nope, that's not it. Step 1. Step 1. That's right. Switch the x and y. Step 2. What do? That's right, kids. Solve for y. Okay, so 24. Switch the x and y. So I get x equals log base 3 of x. Y. All right, solve for y. I got to solve for y. Solve for y. Because that would be my inverse. Huh? You're on the right track, okay? I got to have a power with base 3. So I'm going to make this log base 3 of y into an exponent with base 3. Now, hang on a minute. Whatever I do to the right-hand side or one side, I have to do it to the other, right? My 3 cancels out the log base 3. So what's my answer? Yep, and that's my inverse. I'm going to put a little minus 1 there. See how easy that is? Number 25. Step 1. Switch the x and the y. So I get x equals common log y. What's my base for the log? So I'm going to raise it to the base 10. So my answer is, because there's nothing there, 10. Yep. So I got 10 to the x. These cancel out, equals my y inverse. Because on Friday and on our homework, we learned that the common log, if you don't see a base there, it's a common log with base 10. I practiced it over the weekend on the homework, and therefore I have it in my muscle memory. Watch the video. Okay, number 26. switch x and y. So I have x equals ln of y plus 1. Please don't make the mistake of subtracting 1 first. It's in parentheses. You cannot unlock it yet. What? Hey, shut up. Quiet. What's my base? That's an ln. It's natural log. That's no dot. What's the base for ln? That's right, e. So I'm going to use it for the base of my power. So I have e to the x equals, these cancel out each other. Now I can drop my parentheses because it's all by itself. Y plus 1. Now what? Subtract 1. So my y inverse equals e to the x minus 1. It's not to the power, that's a symbol for, and well, I guess it would be power. Questions on finding inverses. Yes, ma'am. Yes. Now, we are going to do the graphing. This is, we did the graph of the exponential function, right? Hey, guys, quiet down. We did the graph of the exponential function, right? Yes, we did. Now we're going to do the exponent function. Now we're going to do the graph of the log function. This is our parent graph. No. So here's the parent function of the log, the parent function. Function, which is what I wish some of your parents would do, parental. All right, let's plug this into our calculator and see what we get. All right, y equals log of x. Okay, graph, and there's our parent function for the graph. Okay, so let's go ahead and graph this. So I'm going to go to second graph, bring up some points, and we get a whole bunch of this error stuff. So it does exist. We'll talk about it in a minute. Okay, let's go ahead and plot the points we do have. 1, 0. 1, 0. 2.3. 3.5. 4.6. 5.7. 6.8. 7.84. 8.9. 9.95. And we finally get another decent number, 10, 1. Okay, so let's go ahead and graph it. So it looks like it's going something like this. Okay? Agree? All right. Let's talk about these errors. Now, your calculator is actually pretty smart. It can compute these numbers, but our calculator's having a problem putting these on the graph. Because what happens is they're getting really, really, really small. And unfortunately, there's only so many pixels that can fit on these calculator screens. So when it goes to graph it, it comes up error. Okay? Now, if you're not paying attention and you're talking to your buddies and you're watching video games or your phones or throwing shit all over my room, and you don't put the other part of the graph in, I'm going to mark the problem wrong. Okay? The graph actually continues all the way down the y-axis, but never touches or crosses it, right? Yes. Okay, here's my asymptote. In our exponential function, we had a horizontal asymptote. In the log function, we're going to have vertical asymptote. Okay, vertical asymptote. All right, let's see. So we got the vertical. Oh, by the way, what's the equation of our y-axis? What's the equation of the y-axis, our vertical asymptote? It's x equals 0, right? Vertical line at when x equals 0. Okay, what's our x-intercept? Where does it cross our x-axis? 1, 0, right? So either x equal 1, or you can actually put 1, 0. I don't care. Transformations on this graph, well, it's the parent function, so there is none. What's my domain for this graph? What are my x values? 0, comma, infinity. Very good, Will. Because this is my x equals 0, remember, it doesn't cross or touch the 0. Okay, what's my range? Okay, and I caught somebody saying negative infinity, positive infinity for domain because that was the domain for the exponential functions. And for the range, it was our horizontal asymptote, comma, infinity. So because they undo each other, guess what happens to our domain and range? They switch. This is actually our vertical asymptote, comma, infinity. Got it? Now, I'm only going to do one of these transformation problems because we've been doing transformation problems forever. So I'm going to do number 30. Look at number 30. What are my transformations? Right 2, down 3. Good. That's my H, right? And that's my K. Now, we could put this in the calculator and plot all those little tiny points again and do it that way. But we don't need to, okay? First of all, what's my vertical asymptote here? Nope. It moved how many spots? So x equal 2. Vertical asymptote moved to x equal 2. Okay. Okay, so here's what. Quiet. I'm almost done. Now, I'm going to start at our good points up here. Our good points were 1, comma 0, right? And 10, comma 1. Those are some really good 2 points. We can probably just estimate the rest, right? So, Here's 1, comma 0. Now, according to our transformations, I'm just going to go to the right 3 and down, right 2 and down 3. So right 2, down 3. Okay? And the other one was 10, comma 1. So I'm going to go to the right 2 and down 3. Okay, so here's my graph. Easy peasy. What's my domain? What's my vertical asymptote? 2. My h is 2, infinity. Range is always going to be, don't worry about the x-intercept on this one. It's a very large number. Okay, questions, comments, concerns? For practice, I would do these other two. And for practice, you have to do, yes it is, if you do the homework. For practice, do 40, 42, 46, 50, 61, 65, and 74. Now, it took me, again, 4 minutes to do this. I expect you to take 6 minutes. So if you walk out of here with homework, yep. And your